we're going to be talking about sustainability versus availability when using UPS systems. So, and obviously the most important thing is where not to compromise. So let me just move this screen out of the way. So the most commonly Googled sustainability related term this year has been, what is sustainability and what does sustainability mean? So people are still sort of on the search as to what the big encompassing word sustainability is. And where is this actually being driven from? You know, why 2023, why 2024 is this such a big thing? So the word sustainability was originally used by the UN in a paper on sustainability development in 1987 to mean meeting the needs of the present without compromising the needs of the future generation. Pretty self-explanatory. So although this could be seen as a bit of a delayed reaction from us as human beings, could this boost of interest be down to goals set by the United Nations, which are starting to generate serious conversations now, particularly in our industry? The Sustainability Development Goals, the SDGs, also known as the Global Goals, were adopted by the United Nations in 2015. Again, you know, that's some time ago, as a universal call to action to end poverty, protect the planet, and ensure that by 2030, all people enjoy peace and prosperity. That's a lovely thing. You'll even note today on the news, on probably driving into work, that some of the sustainability and planet goals aren't being met, and we're behind. So, you know, why is this taking us so long for everyone to start taking this more seriously? So, since Centiel was founded, sustainability has been a real key driver for us in the design and manufacturing development of tomorrow's power production products. The latest technology within our UPS system sees huge improvements in energy management, the use of energy, and there is a dedicated focus on quality, affordability, the resilience, how available the system is, how safe the system is, and of course, overall sustainability. So at the same time, sustainability development goals are being implemented globally, the demand for energy from data centers is growing rapidly, exponentially. A very, very good reason to enforce sustainability actions now. In 2021, the global data center market size was actually valued at circa $192 billion. According to one source, by 2030, the market size could grow to a whopping $554 billion, which is a compound annual growth rate of about 11% or just over. And according to another source, by 2026, the market size could actually reach $615 billion, which is an accelerated compound annual growth rate of nearly 22%. I mean, huge. So whose projection is actually correct? Well, the truth is we don't really know. We just don't. Regardless of who is predicting what, it is an absolute fact that the data center market is increasing rapidly, and therefore demand for power will increase, and therefore the need for quality power protection will also increase. So some of the largest data centers already consume over 100 megawatts of energy. And with the recent breakthroughs in artificial intelligence, this demand could easily double, if not triple. Basically, as the market grows, data centers will need to consume more and more energy. Clearly, they must be designed or actually adapted with sustainability in mind. With the data center landscape continuing to evolve, designers and operators must consider all the options available to improve the energy efficiency of these facilities, and the selection of equipment is an extremely good place to start. Stratus Power, which was announced on the last slide, is the latest innovation in true modular UPS architecture, uninterruptible power supply systems, that will help to minimize the total cost of ownership and provide complete peace of mind concerning power availability, while helping data centers achieve net zero targets. One of the key features of Stratus Power is its pioneering technology, referred to as DARA, a distributed active redundant architecture where every single component is replicated within the system, which ensures full availability and no single points of failure. Each UPS module within the UPS system is independent, it's redundant, and interconnected, maximizing the mean time between failures, MTBF, and safeguarding the power to critical applications with 9 nines of availability, basically 99.99999% uptime guaranteed. We refer to this technology as the 4th generation of modular design with a layer of sustainability. Product sustainability isn't just how components are sourced or how the product is manufactured, not even just about how it's recycled. It's also about how the user lives with and utilizes that product to maximize its capabilities and make positive improvements throughout their facilities. One of the most impressive operations of this type of product is how it manages energy, and whether that's the ability to manage its own electronics, to only employ what is actually really needed to manage the load, to enhance and hit the sweet spot of that efficiency, or the capability to implement a mode such as peak shaving. So what is peak shaving? Why is peak shaving needed? And how does UPS peak shaving work? So peak shaving can be seen as saving money or being green, but the reality is it's both. Peak shaving is a technique used to help reduce power consumption from the grid during periods of high demand throughout the day. It can help customers avoid paying higher electricity prices or fees that are applied when going above their maximum peak load. It can be achieved by either reducing usage levels by switching off non-essential equipment, or by utilizing other energy sources such as central battery systems and UPS systems. So the problem we've got is UK businesses have experienced significant price increases since 2021, and it's become volatile again in 2022. Although wholesale market prices have fallen, they're still considerably higher than in 2021, and they're expected to rise again in 2024. Unfortunately, no good news. Energy security also continues to pose problems, leaving the wholesale energy market open to further volatility. Basically, prices will continue to fluctuate and rise daily. It's estimated that electricity consumption in the UK and the US will increase by approximately 50% in 2036 and more than double by 2050. Grid operators are therefore keen to find ways to achieve a shaved curve, and so end users will usually be granted a rebate on their energy bills if they implement such a mode as peak shaving programs. So how does it work with the UPS? Well, when the energy cost or demand is at its lowest point, the UPS will operate in its normal mode, taking the required energy from the grid through its electronics and out to the load, whilst continuing to float charge its energy source or its battery bank. Note that the latest UPS system should have efficiencies of 96 to 97% or greater across its load range when operating in true online double conversion mode. As a side to implementing the efficiency to a highly efficient UPS, the latest modular UPSs can also perform a user-enabled maximum energy efficiency mode (MEM). This intelligent system feature works alongside the normal operation of the UPS system and will match the required number of modules or the required amount of power to the load to optimize the sweet spot of efficiency of the system. When the cost of energy increases, or when the demand is too high on the grid, the UPS system is able to take a predetermined amount of power from its battery and the grid simultaneously and automatically to supply to the load. So, for example, rather than taking 100% of the energy from the grid, 30% could be taken from its energy source or its battery, and 70% could be taken from the grid to supply the load. It's important to note that if a UPS system is supporting critical loads, enough autonomy must be left in the system to support that sensitive load in the event of a power disturbance or a power failure, allowing the load to be safely transferred to a secondary source, such as a generator, or to be gracefully shut down. Now, once the UPS has reached the end of its peak shaving period, battery recharge can be held off until the low rate of demand or of energy comes into play. Or alternatively, perhaps the recharging rate could be taken from means such as renewable energies, and therefore the peak shaving operation is potentially completely net zero. Now, to be able to perform this type of operation, the energy storage product that's attached to the UPS must be considered. Whilst the most common energy store for a UPS system is a VRLA battery block, which is widely available, tried and tested, and is relatively green, it is mainly used for standby applications due to its ability to only perform maybe 100 or 200 full cycles in its lifetime. This means that selecting a product that has a long life and can perform thousands of cycles is key to being able to perform this task on a daily basis, if not a weekly basis. And so our attention turns to products such as lithium-ion batteries. So Centiel's LifePower lithium-ion battery solution has been developed using LiFePO4 chemical composition. It's actually one of the safest and most reliable lithium-ion battery solutions available on the market. It's got extremely high power density, a very small footprint, can achieve thousands of cycles. It's got a very long service life, let's say 15 to 20 years. It's got an onboard battery monitoring system, and that's at cell level, at module level, and at frame level, and operates in high temperatures, which means we can even start thinking about reducing costs on cooling. So an important advantage over other lithium-ion chemistries is thermal and chemical stability using LifePower, which improves battery safety. For these batteries, there is not a lot of actual lithium metal in the battery, which is a common misconception. As a result, LiFePO cells are harder to ignite in the event of mishandling, and especially during charging. A common question that I am asked personally when working on UPS and lithium solutions is about safety and fire handling. And with this particular product, you can even look into suppression systems such as water, class A, B, and C fire extinguishers, and CO2 extinguishers. So as you can see, there are various products available on the market. So the key to this is to do your research and your homework when making your selection. The good news is that the cost of purchasing lithium-ion products is decreasing, which helps with the overall total cost of ownership. making the ability to implement modes such as peak shaving more accessible to the market. So that was a very brief insight into the operation of UPS systems and how they can perform certain energy management modes and help facilities save money and energy and be a little bit more greener for the planet. We obviously know that the demand on energy is increasing, the cost of energy is increasing, and we're trying to do everything we can to protect our planet. So if you have any questions, that would be fantastic.
Thanks so much, Louis. Yeah, like you said, this is a huge topic at the moment. We've covered it probably almost in every session that we've had so far. Just a quick question from the audience before we move on. So the session title discusses the drive to be net zero, but what about the rest of the life cycle? Lithium mining has a large carbon footprint. While it's not always recyclable, how do you deal with this in a net zero world?
That's a $1 million question. So one of the comments I've made back on one of the last slides there was the actual quantity of lithium metal that is being used within a product such as Life Power from Centiel. So there are lots of different types of lithium products out there, and the mining of lithium is questionable globally about, not just the sustainability, but impact on human beings and it's a difficult topic. So I would say it's probably the best product available at the moment that uses the smallest amount possible. But lithium has been in our lives for forever. It's in our phones, it's in our cars, it's in most of the products in our home. It's about how that's utilized. The latest news is that the recyclability of lithium is improving. There are more locations around the globe that are able to recycle lithium ion. End-of-life batteries going to energy farms and so on and so forth. I feel like we are slightly at the early days of using lithium, but the more we use it, the more we can save on energy, the more it generates funding to do better things with it and how we utilize it and how we recycle it.
I've just got a couple more questions, if I may. What place does hydrogen have in UPS applications? Is this something Centiel is exploring, like competitors are?
Yeah, I haven't personally seen anything. The only thing that I've personally worked on is integrating our UPS system alongside an already existing hydrogen fuel cell within a building that they use. Again, I think we're at early days with hydrogen. I think we'll probably see that in vehicles faster than we'll see it with proper UPS applications.
Yeah. And as with anything, the more it gets used, the more solutions are developed.
Correct.
It's
another question surrounding safety, which has been a big thing within lithium-ion applications for UPSs.
And then I've got a question in 3 parts. Does the Stratus Power have internal bypass per module?
It has an internal static bypass per module, correct. It also has at frame level as well.
And then are the modules serviceable?
Yeah, completely. I mean, the design surrounding all of our modular UPS systems is about how available they are. And the availability comes down to how they're maintained as well.
Yeah.
So it's about the speed in which that system can be either back up to capacity or back up to the resilient level. So the speed of maintenance is crucial. And that's why we make the modules have a certain architecture so that things like capacitor replacements can be done extremely quickly.
Yeah.
So things like hot works and soldering on sites is a sort of thing of the past when it comes to the latest technology of UPSs.
And then just finally, would not the upfront large investment in a larger than necessary battery bank offset the peak shaving benefits?
Could you repeat that? Sorry, Kaylee.
Sorry. Would the upfront large investment in a larger than necessary battery bank offset the peak shaving benefits?
Yeah, possibly. Sizing of battery banks has has differed throughout the last couple of decades. I think people are getting wiser to not oversizing systems.
Yeah.
Only utilizing what you actually require. Relying on other systems, relying on maintenance regimes to be able to make sure your system is ready to kick into action when it's needed, rather than just relying on putting more lead or more lithium ion into a site. It's actually making sure the whole of the infrastructure is working correctly, so that they can be managed. So it's all about wherever you're doing, whatever, if you're using VRLA batteries or you're using lithium ion, it's about understanding what your power plan is, maintaining that system and making sure that it can cope within a power failure or a disruption scenario. So it's not a straight sort of forward question. It's something where we need to do a bit of joined up discussions and thinking to come up with the correct power plan for someone.
So it's about knowing what you need from the start, basically, and getting it right from the very get-go.
100%. Yeah.
And then just finally, sorry, another question's come in. Could a flywheel UPS be even more eco-friendly than one with a battery? What are your thoughts on flywheel technology?
Flywheel technology. So it depends. It depends what the application is. For critical loads, I mean, from my experience with flywheels, they offer a very short period of ride through. Generally, when you've either got a diesel engine on the back end of a flywheel UPS and a battery bank as well. But you've got a very, very short duration of autonomy to be able to, you certainly wouldn't be able to do peak shaving with flywheel technology. But it all depends on the application, depends on the size of the application, depends on how critical the load is.
So as again, it's knowing what you're dealing with and then coming up with the best solution.
It's certainly not one size fits all. We need to be working with people to work out what the very best solution. I mean, we pride ourselves on being trusted advisors, so we would only advise on a solution that was the best fit for that particular customer. Flywheel technology has its place. Static technology has its place. Lithium-ion, VRLA batteries, they have their place, and it's all dependent on where this can be utilised and what the best gain is for that customer.
Thank you so much, Louis, and for answering that rapid fire question session.
It's okay.
Thank you for joining me today and for giving your time to the event, and have a great rest of your day.
Thank you, Kaylee. All the best.
Thank you.